Okay, so it says evaluate using the squeeze theorem. The squeeze theorem is covered in Math 121. And the problem with that is getting a squeeze for that. And let me write this down for you. So it's going to be x times sine of 1 over x. And I'm looking for a squeeze that's defined on the interval containing the 0, but not exactly at 0. So it doesn't have to be at 0. But I want to get something to the left and the right that's going to be greater than it, than less than it, and let's see if we can do that, all right? Let me erase this over here. And I'm thinking about that, and I realize the sine function kind of bounces around between plus or minus 1, all right? So I'm going to say, let's put this down. So I'm going to say the absolute value of x, and then I'm going to bound it from below by the opposite of that. Now, if you look at this over here, I want to point out to you what that would look like to me. The absolute value of x looks like this, and the absolute value of minus x, the opposite of it, would look like this. And I'm saying that this thing in between, fits in here, over here somehow. And over here, it doesn't have to be at 0, by the way. So I'm going to say that's a good squeeze, by the way. That's a really nice squeeze to get over here. What are you going to do? You're going to use the squeeze theorem now, and you're going to look at the limit of the lower function. We'll put this over here. The limit as x approaches 0. Let's do the lower guy, so it's minus the absolute value of x. Well, that's 0. You're going to look at the upper guy, so it's going to be limit x goes to 0 of the upper guy. That's also 0. So I can conclude by the squeeze theorem that the limit as x goes to 0 of the guy that's in the middle, the sandwich guy, is also equal to 0, all right? And that's pretty much the end of the story, all right? That's stuff all written up for you, and it's certainly neater when I type it up, though, than when I write it down. Thank you.